In the last video where we left off, we built a card object. And the idea with a card object is it would represent a single individual card. And each card would have a face name. All right, there we go, just a little delayed, sorry. Each card would have a face name, so in this case an ace. You would have a suit, like spades, so this is the ace of spades. It would have a value, I'm making it 14 because the ace is the highest card. And then we also gave it an image. And if you do a true model view controller setup, you may not give the card itself the image, maybe you just have that in the view object, or the view class. But I'm going to put it here as part of our card class to really accentuate the point that each card knows things about itself. It in itself is an object. And last week we built that. So we started a card game, and in here we have our card object. And if we built a simple little, built a little bit of a GUI interface here, just so that we could see our card. So if I say run file, we can see that we have a display for a card object. That's just this little main method. But the actual card we instantiated in this case was the ace of spades. And we could also go down to where we created our card. We could create another label if we wanted, but I'm just going to change this to be the Queen of Hearts, which was our other card that we created. And if we run this now, we see that we have the Queen of Hearts come up. So each card knows how to represent itself, both as visually, but we also had here the Ace of Spades has a value of 14, and the Queen of Hearts has a value of 12. So when we got we called the method getFaceValue for the Ace of Spades and Queen of Hearts, we could see that each card was different from itself. They're two individual objects. They're both instances of the card class, but they're different objects. But now what we need to play a game with cards, we actually need to build a deck. So the idea with a deck of cards is that we have to have some kind of container to hold all the cards together. So each card would be an individual card object, an instance of a card. And often what we'll call this is, so we're going to build a new class called DeckOfCards. And you'll hear the phrase has a relationship. So a deck of card has a card object in it. So let's go into NetBeans here. And I'm going to go to our card game, and I'm going to say new class. And in this class, I'm going to call it the deck of cards. Okay, let's just make this nice and big so everyone can see it. There. Okay. So as I said, we want a container that can hold all 52 cards. So in this case, I'm going to use an array. Our data type is a card, right? So we're storing cards, so it's an array of cards, and I'll just call that the deck, right? The deck of cards. And I'm going to create an instance variable as well called the current card. So the idea with the current card is it's the index of the next card to be dealt. Okay. Now, when you're building a deck of cards, you could actually create enums for all the suits and all the names of the card. It actually is a little more robust than the way I'm about to do it. The way I'm going to do it is actually just for speed and simplicity. So first, let's build our constructor. So again, the constructors, our class name here is deck of cards. And when we want to create a new instance of a deck of cards, we will call this constructor. In this case, we don't need to pass anything in because every deck of cards is going to be the same. If you wanted to create a deck of cards, maybe with more than 52 cards, like maybe include the jokers or you want to include some kind of graphic into it, maybe you could have a different constructor. But we're going to do a pretty basic constructor. So first thing I'm going to do is I'm going to create two little arrays that will step through basically everything we need to set. So the constructor's got to create 52 cards. So basically what I'm going to do is I'm going to create an array with all the face names and another array with all the suit names. And then we're going to take a single image and we're going to break it up into all the different images of the cards. So this array will capture all of the names of the cards, the face names. And again, it is probably better practice to make these enums, but we're going to do it this nice kind of quick way today. So that's all the faces, and then we'll do all the suits. And I'm going to use a generic image here called all cards. And it looks like this. So what we're going to do is we're going to step through this image, and it's going to go diamonds, then clubs, then hearts, then spades. So that's why in here I've set up diamonds, clubs, hearts, and spades. It matches the order that this deck of cards is. Okay, so my deck is equal to a new deck with 52 cards in it. Okay, it has 52 instances of card objects. So that's why we have an array of type card. And our current card will be equal to 0. We're going to look at the top of the deck. And then the following information, as I said, I'm going to use this generic file. So when you go online sometimes, if you're looking for some images, you can find, so for example, card images. Click on images. You'll often get these sets so that you can use individual cards. They're all match versus trying to get 52 individual card images. Okay, so that's what we're going to do. And our strategy for pulling these out is, this is one big image, but there's a method called get subimage in the available to us, and you basically give it the starting XY coordinate, and then the width and the height of each card. And so what we'll do is we'll figure that out for the first card and then the second card. So each time we just have to give it the starting coordinate of the upper left corner, and it will be able to pull out the card. So let's do that. So information. I'm going to make these final, just meaning that I don't want them to change. Right, so we have 4 rows by 13 columns, right? So if we look at our image, we've got 4 rows, 1, 2, 3, 4 by 13 images, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. And if you think about it, what I want to do is I want to do the exact same thing for the 2 of diamonds that I want to do for the 3 of diamonds. The only thing that's going to change is where my starting XY coordinate, and then when I create the instance of the card, I want to step through from 2 to 3 to 4. So since I want to do the same thing over and over again 52 times, what I'm going to do is I'm going to use a loop. I'm actually going to use two loops. One loop to go over the rows and one loop to go over the columns. So in this case, I'm going to say for. I'm going to call it the suit. Okay? So my rows will be the suit. And then my columns will be the faces. Or I'll call it the face num. So the first thing I'll do is I'll extract the image. So to do that, I need to first use something called a buffered image. We use that in our card class just to test it. So I'll make the big image is equal to and we'll add in here, we're going to add in the import for the IO class, the file IO class. So there's basically three things we're doing here. So one, we're using a buffered image class. So we're going to create an instance of the buffered image class, and we're calling that big image. And then we're going to use a static version of the image IO class to read this file. And in order to do that, we're going to use the file class so it knows how to read it. So we're going to add in some imports here. And then we're going to have to add in a way to handle the throws clause. Okay, so now we can see this is still underlined. And if I hover over this, let's go over to our light bulb here. It says unreported exception, an IO exception. It must be caught or declared to be thrown. So I could do a try and then catch with this. So that if it can't read this file, it could gracefully handle it. It wouldn't error right out. In the case of what we're going to do today, I'm just going to say add a throws clause. So what this means is if it can't find this file, it's going to stop the program execution, and it's going to show me what the error was, which is fine for this type of a program. And then I'm going to use buffered image class again to create a temp image. Right? It's the smaller image of a specific card. Okay, so now I have this, I'm calling this whole picture big image, and when I extract an individual card, I'm going to call that the temporary card image. So let's extract it. So the temporary card image is equal to the big image. Now again, because we're using this buffered image class, we can actually use its methods. And one of those is get sub image. Okay, and then we basically have to give it a few parameters. So we need to give it. So because we're using this buffered image class, we can use the methods for it, and that includes the get sub image method. And I'm going to break this down over a few lines just so you can really see what's going on. And although it's assumed the suit, that's not really what we're going to use. This is the starting x coordinate. This is the starting y coordinate. This is the width of the image. And this one is going to be the height of the image. So here, what I'm going to do is I'm going to use whatever face number we're on, right? So if we're on, the first one, second one, third one, etc., right? So it knows how far over to look. And then the thing is, so it's the face number times the width, right? Because each card has a width. So, if I'm on 0, which would be the first one here, and then I got to go over to basically what we're calling position 1, right? Which holds the 3. So that's why I'm using the width of each card, but we have to account for one other thing. There's this little bit of black in between each card. So I'm going to say it's face number times the width plus the face number times 9. So there's about 9 pixels between each card. So what that'll do is if it's, if we're on position 0, well, there's no black. And then if we're on card, what's going to be number 1 here, we just have to deal with 9 pixels. And if we're on the next one, we're going to have to deal with 18 pixels. Okay, so just a little formula to get us in the right starting x coordinate. And then the next is whatever suit or row we're on times the height of each card. Okay, so if we're on row 0, so to speak, or suits 0, then we don't have to add any height at all. If we're down here where suits would be equal to 1, we have to go the height of this card plus this little black bit here. So it's going to be suit times height plus suit times, and it's actually 14 pixels in this particular image. And if you get a different image, you might have to use some different numbers there. And then you have to just put in the width and the height of each one. I'll just move my comments over so it looks nice. And we need a semicolon to finish it off. Okay. So now at this point, what we would have is we have the suit number, we have the face number, right? So we can use those, right? So suit 0, face could be 0 in the first implementation, so it'd be the 2 of diamonds. We're able to extract the image. So really what we need to do now is we need to create a new instance of our card. So I'm going to say the deck, right? Because we're building a deck of cards. And I'm going to do a little math here. So I'm going to say whatever the face number is plus suit times 13. Because remember, we're building an array. So why isn't it seeing the face num? Yeah. So I need to do it inside of that bracket. Okay. So the first time through, face number would be 0, suits would be 0. So we're going to say the deck at position 0. So if I go to, so if I go to our deck of cards, let's just view that a little bit bigger. So our deck of cards has 52 positions in it. So the first position here is position 0, because computers start counting from 0. The next position is position 1, and then 2. And this will go all the way across, and there'll be 13, right, for each suit. So that's where, if you look at this, it's whatever the face number is plus 13 cards for each suit. So if we're on our second implementation through, it'd start counting on position 14. Okay, so then now we're going to create, so in position 0, we're going to create a new card object, and we have to pass in the suit, right? So if we go back to our card object and we create a new card, we go suit, and then the face name, the value, and then the image. So let's do that. Let's go to our deck of cards. So first it's the suit. So we have, if we scroll up a little, we have this array of suits. So I'm going to say suits. So I'm going to call that array at position suit, right? So that way I can use this this for loop to pick off each of the suits in order. So that's our first one. Then we need to pull off the actual face name, and maybe what I'll do is I'll do this in stages here. And then the next one we have is faces at face number. Okay, and then, so if we go back to our card object, So now we've got the suit, we've got the face name. Next thing we need is the value of the card. So again, I'm going to do a little bit of math here. And I'm going to say it's the face number plus 2. So for example, if we're at position 0, the first card is a 2. So I'm going to say 0 plus 2. So I'll get the value of this card as a 2. And then we go to position 1, it's going to be the value of 1 plus 2, which equals 3, etc., all the way through our cards. And then the last thing we need to do is set our card image, which in this case is going to be the temp card image that we have extracted right here inside of our loop. Add a bracket. So there we've created, in each position of our deck of cards, we've created a new card object. Okay. So when you're creating methods, or sorry, when you're creating a class, you need to think about, so this will set up all of our instance variables. So when we create a new instance of a deck of cards, we'll get 52 new cards. And if I want to test this, I can actually, so this is the end of the constructor. And this is the end of the class. So if I go in here and I create a main method, so I say public static void main, I can test our deck. So if I wanted to create a new deck of cards, I'm going to say deck of cards equals, I'll call it the deck is equal to new deck of cards. And it's saying there's an unreported IO exception. So the reason is when we call the constructor for a deck of cards, we said that constructor will throw an IO exception. So all we have to do is I'm going to go over to my light bulb here, left click, and it says add throws clause. So there we go. And one of the things we'll do is let's create a little method so the deck can display itself. So I'm going to say public void display deck. Oops. Do it as a loop. So where we are right now, we've created a very simple, it's an enhanced for loop that allows us to, it traverses over our deck of cards, and in each position of the deck, we have a card object. And I've called that instance of a card, with just a lowercase c, so it is a different spelling, right, because it is case sensitive. And all we're going to do is we're going to print that card on a new line. And because cards know how to represent themselves, we should be able to see our deck of cards when we call. So I'm going to say the deck and display deck. So let's run this. So now we're going to, should see, okay, it said it can't read the input file, which means I probably haven't put it in the right spot. So let's take a copy of this, and we are working on the card game. Aha, so here I only have the Ace of Spades and Queen of Hearts. I haven't actually added in all cards. So this error we got, it says, well, I can't read the input file. Yeah, because it wasn't there. So let's try that again. We're going to run the file, and what we can see is here our display deck stepped through our deck of cards, and we got the 2 of diamonds, 3 of diamonds. So we got all of our diamonds, and then we started doing through the clubs, and then the hearts, and then the spades. So it looks like it's working. Now, when you take a deck of cards out of a box, you don't normally just deal the cards as they were. I mean, you need to shuffle them in some way. So our deck of cards class needs a method for shuffling. So let me just add a little comment here. This method. So we need this ability to shuffle cards. So the method that we're going to use is actually a fairly simple concept. I'm going to take the card from the top of the deck, pick a random card somewhere in the deck, and swap them. And I'm going to do that 52 times. So every card in the deck will have been swapped with another random card. And that should shuffle the deck. So let's give that a try. So put a little comment here. Looks like my editor picked up on my main method, so we won't have any parameters for this one. So I'm just going to say public. It won't return anything, so our return type will be void, and I'm going to call it shuffle. Okay. So first thing, once we shuffle the deck, we'll reset the current card to be equal to 0, right? Because remember, the current card is an instance variable that we have up here. So I go to the top of our class. There's this instance variable current card that points to the next card to be dealt. So if we shuffle the deck, no matter where the current card is, we should put it back to 0. We deal from the top of the deck. And for each card in the deck, pick another random card and swap them. So I'm calling it first. You could call it anything you want, index, but this is the first card. Then we're going to select a random card. And to do that, I'm actually going to use a class that we haven't used before, and it's called secure random. So secure random is very similar to the random class. The difference with secure random is the random class is pseudo random, meaning if you had enough information about, I guess, the date and the time, you could figure out what the random number will be, whereas secure random is, I guess, a little more robustly unique, or not unique, strong term, but random. So I'm just going to call it a random number. So I'm going to create a new instance of the secure random class. Okay, and let's just add an import. So now when we select a random card, I can say that our second number here, or second random number, next int, and there's 52 cards in the deck, so we'll get a random number between 0 and 51. And then we just swap the cards. So I'm going to create card temp that is equal to the deck in the first position, right? So remember, the deck's an array of cards. So when I say deck at first, wherever position we are in this for loop, it'll pull that card out of the deck. Well, won't pull it out, but it will give a copy of it, and we're going to store it in this variable called temp, which is also a card object. And then we're going to say the deck in that first position, right, is now equal to the deck whatever our random number was, the second position. And then we'll say the deck second position is equal to that temp card, right? So we've effectively swapped two cards. Clean up our spacing a bit here. So now if I want to shuffle the deck, I can say the deck dot shuffle. And I could say system.out just to test this until then. After shuffling, deck looks like, and I can say the deck dot display. So let's run this file now that we've had the ability to shuffle. Okay, so originally when we run it, you can see everything's in order. 2, 3, 4, 5, 6. You can see it goes very much in order. Then after shuffling, we go 4, 5, 8, 5, 10. You can see the we're going spades, hearts, spades, diamonds, hearts. So it is shuffled for sure. So now we have the ability to shuffle our cards. And the last thing that you would do with a deck of cards is actually deal cards from the deck. Now in this case, we don't actually remove the cards from the array, but what we do is we'll give a copy of the card, so to speak. So let's create a method called deal. So in this one, I'm going to say public, and because it's going to deal a card, what it should return is a card object. And then we have to do a little check, because remember we have a pointer that's looking at our deck of cards, right? So after we deal, before we deal anything, it's pointing to this first card. And then after we deal, it's going to point to this card, and then the next card. Well, we have to check if this thing's still pointing to a card inside of our deck. If we get to the point where the pointer's beyond the end of the deck, we've dealt all the cards. So to do that, we can just check. We can say, well, if current card variable, right? This is the instance variable. Current card is less than the length of the deck, right? That means it's still looking inside the deck. So we just return whatever card is there. So I can say the deck at the current card. And then what's neat is this plus plus. You'll actually return the current card, and after it's done that, it will increment the counter. And otherwise, right? So otherwise, I'm going to return null because we have no cards left to return. So now we have the ability to deal a card. So let's just add a little comment here. Say this will deal a card off the Okay, so there we go. So now we have a deck of cards, right? And remember, this is a has a type relationship, right? So our deck of cards class has a array of cards, and it has an integer to figure out where we're looking in the deck of cards. In our next video, what we'll do is we're going to take this deck of cards and create the game of war. Look forward to seeing you then.